In the last video, we took a look at this algebraic function and its limit as we went off to positive infinity. Now we're going to take a look at the limit as we go off to negative infinity. A lot of the work is going to be very similar. I'm going to start by multiplying by 1. And 1 in the form of the reciprocal of the biggest power root combination of x that I have on the bottom. So if I look, all the powers of x are under the square root, and the biggest power is x squared. So we're looking at the reciprocal of the square root of x squared. So that gives us the limit as x goes to negative infinity. Now on top, I can go ahead and distribute that. So we get 3x over root x squared minus 1 over root x squared. It's distributed, but it's not going to be very easy to cancel because I've got x's not under a root and x's under a root. On bottom, I can't really distribute just yet, but I can say this is root 4x squared minus 2x. That's just one thing over root x squared. Now on bottom, we're going to use the fact that square roots distribute over division problems. So rather than saying it's this root divided by that root, I can just write that as one big square root of the top divided by the bottom. So I'm going to say this is the limit as x goes to negative infinity of. On bottom, we'll just write one big square root of 4x squared minus 2x over x squared. I'm going to come back and simplify the top in a moment. But once I've got everything under that root, I can now distribute that x squared under the radical. So I can say it's 4x squared over x squared minus 2x over x squared. All right, and once I've done that, again, we're still going to have to figure out the top of this fraction, but once I've done that, I can cancel some x's. So this is the square root of 4 minus 2 over x. Now on top, I want to be able to cancel, but I cannot cancel as long as I've got some x's not under a root and some x's under a root. So I'm going to use this same rule that we talked about last time, that the square root of x squared is the absolute value of x, and that's a piecewise function. That just gives me x if x was not negative to begin with, but it gives me the opposite of x if x was negative. Now here we're taking the limit as x is going to negative infinity. If x is big and negative, it's negative. So we're going to be using this rule. So I'm going to replace that square root of x squared with the opposite of x. Now, I can cancel, but what I'm canceling is just the x's. That negative sign doesn't cancel. Okay. So nothing cancels over here, so I'm going to have negative 3, and I'm just going to write that as plus 1 over x. I can combine the two negative signs to get a plus. So the top simplifies to negative 3 plus 1 over x. And now I can look at this, and the pieces that have an x in the denominator are going to go to 0. And what that's going to then is negative 3 over root 4, or negative 3 over 2. Remember how at the beginning of the last video, we said that as we're going off to negative infinity, this is representing something negative. So there was no way we could take the limit and get something positive, which is what we got when we took the limit as we went off to positive infinity. Okay. So the difference is in how we simplify the square root of x squared. It is not always the same as x. The square root of x squared isn't negative. So if x isn't negative, then the square root of x squared is just x. But if x is negative, the square root of x squared is the opposite of x. Now, as you're evaluating these things, I want to see that work justified. So I need to see somewhere that the square root of x squared becomes the absolute value of x, and then that becomes either x or the opposite of x, depending on the sign of x. You can do what I've done here and write that off to the side. That's totally fine. You could, if you preferred, have said, instead of going right to the opposite of x, you could have said, okay, here I'm going to write the absolute value of x, and then in the next step I'll write the opposite of x. But I want to see the square root of x squared, then the absolute value of x, and then the x or the opposite of x. Okay. Reason I'm very, very picky about that is because a lot of students are confused about this. So if we happen to be going off to positive infinity, so that the square root of x squared ends up just being x, if you didn't write that absolute value in there, I can't tell the difference between you thought that step and thought it correctly, or you assumed incorrectly that the square root of x squared is always x. And if we're going off to negative infinity, and you put the negative sign, I can't, again, tell the difference between, well, you thought through the process correctly and figured it out, or you threw in a negative because you knew these problems were weird and sometimes you had to throw in a negative. Okay. So I want to see square root of x squared, the absolute value of x, and then you're making the right choice for how that simplifies. That's my expectation as far as showing work goes for this sort of problem. And we'll take a look at one more example in the next video.